Okay, good morning. Welcome to
FamilyMath203a.
203a. Today we're going to do two proofs. And I'm going to ask you what you think of them. And we've done this, I think, once before, maybe more than once. Do you remember when we did it before?
The 99999.99999 proof.
Yeah. And then I guess we did it with the 1 plus 2 plus 3 plus 4 equals minus 1/12.
Ah,
You don't like that one, do you?
no.
That's good. It's good you don't like that one. Well, today we're going to talk about the area of the circle. Can somebody tell me how, not what the number pi is, but how you define pi?
The ratio of the circumference over diameter.
Circumference over diameter of what?
Of a circle.
Of a circle. Okay, and I'm going to show you how just from this definition that we can find the area of a circle. Now, we don't really know how to find the area of very many shapes.
No.
Here's a circle with radius. R and pi is the ratio of the circumference to the diameter. Oh, sorry, I should probably. The diameter is 2 radiuses, right?
Yeah.
Okay. What do we know how to find the area of?
You know how to find the area of like rectangles and squares.
Rectangles and squares, and anything else? You
Triangles.
know one of those. You know triangles. We just learned about Heron's formula, actually. That's really cool. But this isn't a shape we know how to find the area.
No.
Okay. But I can show you. In fact, actually, I can do something kind of neat to try to transform it into a shape we know how to do. I can chop it up into 4 pieces, and I can arrange them together. Got my little wedges. Ooh, dear. Let's try it. Let's try to draw that a little better. Sorry. That's a little better.
Almost a 90-degree angle.
Yeah, they're supposed to be 90-degree angles, actually. So I take these 4 wedges and put them together like that. I know it's not a perfect drawing, but
And then these sort of look like a rectangle.
well, you can sort of see some straight lines on the sides.
Yeah, but we don't see any straight lines.
Sort of draw a rectangle around
You
it.
could draw a rectangle around it, so you can now start bounding the area. I guess we could have done that here too. But the interesting thing is, 2 of these wedges together, when you go along them, how far do you go?
That's
Half the perimeter.
half the circumference.
Right, half the circumference. 2 of the wedges make half the circumference.
So this would be if you put the 4 curved sides of the wedges together, you would get the circumference.
Yeah, very good. Very good. So what I'm going to do, this maybe looks promising. It's starting to look at least more rectangular. Maybe it's going to turn into a triangle. Who knows? But at least it has a straight side here and
And a
here.
few straight sides.
So what I'm going to do is I'm going to chop these up into smaller wedges. And I wonder if it'll get easier to draw. So I chop each one of these now into 2 pi wedges for Thanksgiving. Okay, so now I got 4 on the top. And they go 1, 2, 3, 4, and they come down and they make wedges. And they fit together really nicely on the bottom. 1, 2, 3, 4.
So it's starting to look a little more rectangular.
Okay, what do you notice about the top?
It's sort of becoming flatter.
Becoming flatter. Anything else can you say about the top?
There used to be 2 bumps on the top, and now there's 4 bumps.
But
Yep.
it's still half the circumference.
How come?
Well, because this here used to be just 1 wedge, and we chopped it up into 2 wedges.
Okay.
So 2 of these would equal 1 of these. So we still have the same top and bottom.
Okay. It takes me 4 wedges to go halfway around. I got 4 wedges on the top, 4 wedges on the bottom.
Yeah.
Okay. All right.
And
Maybe if we chop it up more, it'll look more rectangular.
Okay.
maybe we can just keep chopping it up.
Yeah, I'll do it one more time, and now I'll have 8 bumps on the top, 8 bumps on the bottom. But you can see when I have
That one.
this one, I should have drawn that dashed line. You can see even on the circle, these wedges are starting to look like triangles, even though they're a little bit curved.
Yeah.
And I've got 1, 2, 3, 4, 5, 6, 7, 8 to go.
Yeah.
Oh, sorry, I missed that. 1, 2, 3, 4, 5, 6, 7, 8. Sorry about that. To go across the circle. So I got 1, 2, 3, 4, 5, 6, 7, 8. And I got some thin wedges. My drawing skills aren't there for this project.
And we've got the wedge.
Okay.
And we've got the
1, 2, 3, 4, 5, 6, 7, 8. Okay.
And then
This is definitely looking more and more rectangular.
So-
It's starting to look more and more
if
rectangular.
you, I think if you do this for infinity, you would get a rectangle.
It seems like we're going to get a rectangle. How long is the top of that rectangle going to be
Well,
if I
it's
get
half-
that
It's
rectangle?
half the circumference.
So half the circumference is pi times the diameter divided by 2. That's half the circumference. What's the diameter divided by 2?
it's the radius.
So pi times the radius.
And that's
Okay.
half.
Okay, this is how long our rectangle is going to be. How tall is this
And
rectangle?
This is radius high.
How come?
Because each of these slices is a
And-
part of the circle. Because if you look here, you can sort of see it.
Yeah, and each of these lines is one of the radii.
Okay, so if I do infinitely many slices, the length on top and bottom always stays the same, pi times r.
And then
The height is always r, so what's the area of this rectangle?
Well, if it's going to be
Pi
pi r squared.
Pi r squared. What else, what other area does this sum of wedges represent?
It's the area of a circle.
It's the area of the circle. So the area of the circle has to be
pi
r
r
squared.
squared.
pretty cool, right?
Yeah.
Oh, sorry, high five.
Uh,
Pretty cool, right?
Yeah.
Now, I'll ask you first, and you first. Do you believe this proof?
Well, yeah, it could work.
I know it could. Lots of things could work, but do you believe it? Yes or no?
Yeah, I do.
You do. Okay. Do you believe this proof?
I don't really think that a circle could turn into a rectangle. If you can't really do it for infinity.
Oh, okay. So there might be a problem. So do you believe this proof?
No.
No, you don't. Okay. So I got one believe, one not believe. Okay. Ready for the next one?
Yeah.
All right.